So in this video I'd like to talk a little bit about conjugates. So recall that a complex number is a number of the form z equals x plus iy, where x and y are real numbers, and this I was called the imaginary unit, which we defined to be I squared equals minus 1. So I'm now going to talk about something called the conjugate, and all the conjugate is just a reversal of the imaginary part, the reversal of the sign of the imaginary part. So what do I mean by that? Well, z equals x plus iy, so if I reverse this sign it becomes a minus. So the conjugate of z is just x minus iy. So basically you take the imaginary part of z and multiply that by minus 1. By the way, another notation for this, other than z bar, so that's a complex number, the bar over it, sometimes people like to write z star. I myself prefer this notation, but this notation is equally valid. So let's look at some examples. Let's try to find the conjugate of 3 plus 7i. Well, to find the conjugate, we just multiply the imaginary part by minus 1. So the conjugate of 3 plus 7i is just 3 minus 7i. So let's now try to find the conjugate of 6 minus 2i. Again, you just reverse the sign of the imaginary part. Here it's a minus, so that becomes a plus. So the conjugate of 6 minus 2i is just 6 plus 2i. That's simple enough. Let's look at the conjugate of minus i. Well, minus I is the same as 0 minus I. So the conjugate of minus I is exactly the same as the conjugate of 0 minus I. Now if we reverse the sign of this, that becomes 0 plus I, which is just I. So the conjugate of minus I is always I. Let's look at the double conjugate of 3 plus 4i. That means I take the conjugate and find the conjugate again. So what is this? Well, the conjugate of 3 plus 4i is just 3 minus 4i. So the conjugate of 3 plus 4i is 3 minus 4i. And we've got this extra bar over the top. We now find the conjugate of this again, and that's just 3 plus 4i. So you notice that when I take the conjugate twice, I get back my original number. And this is true for any complex number. If I take the conjugate of something twice, I always get my original complex number back. Let's look at that final example. Let's find the conjugate of the real number 3. Well, 3 is the same thing as 3 plus 0i. And if you find the conjugate of that, that's just 3 minus 0i. But 0 times I is just 0, so this is the same as 3. In fact, in general, if I take the conjugate of any real number, I just get the real number back. Because remember, the conjugate is all about finding or taking the imaginary part and multiplying that by minus 1. You reverse the sign. But there's no imaginary part here. The imaginary part is just 0. So the conjugate of any real number is just the real number again.